In this video, we're going to look at different types of data in R. So just a couple quick notes here before we get started. I have the module 3.1 script open, and this is available for you on Canvas. Also, just as a reminder, remember we can always move these windows around if you need to make the window bigger to see text. You'll notice that this script has more comments than we typically saw last week, and moving forward you'll probably see more comments in the scripts just as I add in more notes and things for you to see. The other thing is in the video, I've made the font bigger than we did previously, so if this helps, let me know, or if it needs to be even bigger for the videos. For your own personal use, if you would like this to be bigger on your computer, let me just quickly remind you how to change some of those options and how RStudio looks. So if you go up to Help, and if we go over to Tools, not Help, we go to Tools, Global Options, and Appearance. Remember that we could change the color and the editor theme, and part of this is we can change the font size, so you can play around with here and find the font size that is best for you. Alright, so as always, I'm starting out my script with just kind of a bigger comment so that when I open up the script I immediately know, okay, what was the purpose of this script and why was I working in it. And so as usual I always put my name and then the date that you're working on this. So previously we already looked at how to define objects. We looked at a couple different types of objects. In particular, we looked at data frames and we looked at vectors. We're going to dive into this idea even further and talk some more about different data types. One of the reasons it's so important to understand different data types, even if you don't work with those particular data types, many times the errors that we get in R or the functions that we use require our data to be in a certain type or set up a certain way. And so the better understanding we have of how data is structured in R and different data types, it's going to help us troubleshoot our code better. So that's why we're going to start out here. So just a couple different data types that you'll come across in R. There are vectors, matrices, and arrays. We're going to talk about those today. There are what are called logical. These are essentially true, false. And so you'll see as we use different functions in R, true, false is used a lot of times to turn different things on and off. So you'll see a lot of the true, false, even though you might not actually code those yourself. Next time in Module 3.2, we're going to cover what are called lists. Factors are a special type of character is one way to think of them, and we'll talk about factors later on. But factors are going to be very important when we cover how to analyze or how to visualize and analyze categorical data. Last time we talked about characters and strings, and we also talked about data frames, and we're going to cover data frames a lot more as we move through the course because it's going to be one of the primary data types that we work with. The other comment I want to make here is hopefully you have seen on Canvas there are recommended readings in the text. Highly recommend going through those. Those are going to cover what we talk about in the videos in even more detail. They're also going to give additional coding examples. And don't forget the books that we use are free and they're easily available for you online. So I do recommend looking through those sections. All right. So we're going to start out by just looking at some helpful functions to use when dealing with different and possibly uncertain data types. So I'm just going to define an object and set it equal to the number 1. So I'm going to highlight this and run it. Notice up here I now have object and 1 in my global environment. So let's learn a little bit about this object. We could use length to find the number of elements or components in the object, and we can see there is 1. The structure function, use str, tells us the structure of an object. So we can see that this is stored as a number. It has 1. Class, it's numeric. Sorry, I shouldn't have said number here. I should have said numeric with length 1. And then we can see if there are any names associated. And in this case, there are no names. And notice since there were no names, R came back with null, N-U-L-L. So let's talk a little bit about what that null means. So in R, it's important to understand the difference between 0, null, and NaN. Okay, so 0 is the actual numeric value 0. So you can perform operations with 0. So for example, we know that 2 plus 0 is equal to 2. So we can do things with 0. Null is a non-numeric value, and you can think of it as a placeholder. And then NA or NaN, which are sometimes used interchangeably, but in R they do have slightly different meanings. Na explains that the data is just missing for unknown reasons, and NaN stands for not a number. It is a numeric data type value representing an undefined or representable value. And on Canvas I've included a little picture that you'll see that kind of illustrates the difference between these. So if this were a computer science course, we would really dive into this difference here. But from a data standpoint, it's just good to know at the surface level the difference in these and the different error codes that they're going to produce. Because depending on which one you use will depend on the error code that you get, and you may or may not have used the correct one. Also, in terms of data, thinking about how we code missing data is very important. And this is something we always want to kind of keep in the back of our mind. Some people, and this is very poor practice, will code missing data with a 0. We want to make sure we don't do that because, again, 0 is an actual numeric value. So we'll find out in R, when we work more with data, missing values a lot of times are going to be stored as the NA. All right, so let's look at a little illustration here. So I've constructed some different vectors, and we're going to take the means of them. So remember that we can always define a vector inside of the function call. So here I'm making a vector that has 0, 1, and 2. So what we can do is just highlight that piece of code and run it. Notice down here at the bottom I get the vector 0, 1, and 2. And now I can run the whole thing to take the mean of that. Well, if I take the average of 0, 1, and 2, of course that's going to be equal to 1. So notice that 0 here is part of the operations. I could define another vector null, or probably that has null instead of the 0. So notice if I just run the vector portion of the code, I can see that the vector return is just 1 and 2. So that null, there is nothing there. Okay. So let's try to take the mean and see what happens. So notice the mean here is just the mean of 1 and 2. Now if you'll recall, we talked about a little bit about vectors previously, and remember that when we create a vector, it all has to be of the same type. So here I'm going to create a vector that the first element is the character A, and then I have 1 and 2. Well, the first thing to remember that when I run this, R is going to coerce the 1 and 2 to be seen as characters. So now nothing in this vector is numeric, so it wouldn't make sense to take the mean of it. So let's see what R is going to tell us. If we try to take the mean here, notice R is going to give us NA. And so NA says the data is just missing for unknown reasons. Okay. And the reason for this is it says, hey, if you're going to try to use that mean function, you have to give me either something that's numeric or logical. And so remember that logical is true or false, but R stores those as 1 and 0, so it can still take the average of logical vectors. So anytime that you get an error that looks something like this and it says the argument is not numeric or logical, that means that you have tried to apply a function that requires numbers to characters. So you get the NA argument there. So in other words, nothing's produced. Really common mistake that happens, and so you always want to check for that. If you ever get a function that's returning the NA and that wasn't something you're expecting, that usually means your data type's wrong. And then finally, the vector that we're going to create here, see what it looks like. Now see it has NaN 1 and 2. So remember, something that is not a number. So let's take the mean of this and see what happens. And notice this time it says, hey, not a mean, not a number. You can't take the mean here. And so this is slightly different than what happened up here when we took the mean, and it is that slight difference between the NA and the NaN argument. But again, we won't go too deep into that. Again, just something to be aware of. Usually when you see something like this, this means that your data is in an incorrect type, so you always want to go back and double check that. All right. So previously in the course we have discussed vectors, but now we're going to discuss them a little bit more in depth. Now for most of you, if you're working with data, again, you're going to be working with data frames. You're probably not going to work with vectors, matrices, or arrays, but understanding their basic structure and how to work with them in R can better help understand how to use some of the functions and will help understand how to manipulate data when it's in the data frame format. Right. So vectors is a basic data structure in R. A vector contains elements of the same type. So we saw that up here when we tried to make a vector that contained both characters and numeric. R says no, they're going to all have to be characters, because obviously it can't change A into a number, but it can change 1 and 2 into a characters. So the types can be the following. So these are different types of vectors that you can have. You can have logical, that's going to have true, false, and NA is included in there. It could be an integer. It could be what is called a double. It's a historical anomaly that R has 2 names for floating point vectors. If you don't know what that is, don't worry too much. Again, that goes back to the computer science side of things where we're not going to focus on too much, but for those of you that do know about this, you've got double and numeric, formerly how it was called real. And if you want to read more about that, I have some information here that you can read. You could have character, you could have complex, and you could have raw, where raw is a vector used to represent a raw sequence of bits. So again, don't worry too much about that. We won't be working with raw in this course. Again, in the recommended reading is more information on all of these types, so I do recommend you looking through that. So we can always check to see what type of vector we have using the type of function, and we're going to see that. So again, I'm not going to spend too much time talking about the different types, but you do need to be aware of it. So let's see how this looks. So first, we're going to create a vector that contains the numbers 10, 20, 30, 40, and 50. And so just as a reminder, the assignment operator, we can either use the equal sign or we can use the arrow. Either one is perfectly fine. So let's create this vector. So we've assigned the object y to be a vector containing 10, 20, 30, 40, and 50. In order to call this object, remember we can just write the name of the object and run that by itself. Now something else that I didn't show you previously, there is another way that when you make an assignment, you can automatically call the value for that assignment. And so let me show you how to do that. So all I'm going to do here is copy the code that I have up above. When you write the line of code that makes the assignment, if you put open and close parentheses around that entire assignment and you run it, notice down here it will make the assignment and it will output that vector. Oops, did I miss something there? I was going to say that doesn't look correct. There we go. So let me run that again. So notice now y is correct. And again, we can see it made the assignment and it outputted. So how you choose to do that, entirely up to you. We saw before that we can call different elements of vectors, and we can do this using the square bracket notation. So if I want to display the second element of y, I have y bracket. I want the second element, so I put a 2, and then I close the bracket. So this returns 20. This bracket notation, we use this with data frames as well. So for a lot of the data types we use, whether it be vectors, matrices, arrays, lists, which we're going to see later on, or the data frames, that bracket notation helps us call individual elements or pieces of the objects. And now let's use that type of function to see what type of data y is, and we can see that it is double, and again because this is a vector that has those numbers in it. Alright. So there are lots and lots of ways to explore the attributes of vectors. I am not going to run all of these. I will let you all run all of these on your own. So this is a good time to pause the video. Hopefully you've got the script open and go through and run all of these and see, corresponding with the comments that I have here, see what these different things are going to produce. And one thing to notice is, so here, we're calling different elements using bracket notation. Here we're applying functions to the vector. And here we're making an assignment that is equal to the function applied to the vector. So a lot of the different pieces that we saw before, we're kind of combining all of those. We're using some of those base functions here that we talked about before. All right. So the next thing that I want to talk about is a little bit about logical operators and the which function. The which function is a very powerful function. I think the first couple times you use it, it can be a little bit confusing, but when it comes to exploring data, it can be really powerful. So what the which function does is, for a vector, it's going to help us find elements of the vector that have certain characteristics. All right, so first thing we're going to do is we're going to use a logic operator. So this is the greater than operator. And what it's doing is it's going to ask R, okay, if we have this vector y, which has the elements 10, 20, 30, 40, and 50, we want to find y greater than 20. So before we run this line of code, if we think about what our vector looks like, we've got 10, 20, 30, 40, and 50. R should tell me in some way that the last three elements are greater than 20 and the first two are not greater than 20. So let's see what this looks like. So let's run this. Notice the output down here, we get the output, each element in this output corresponds to an element of the vector, and it contains a logic element that tells me whether or not the corresponding element in y is greater than 20. So we see that the first two are not, and the last three are. So what I'm going to do now is I'm going to assign a new object, and that object is going to be greater than 20, or greater underscore 20, and I'm going to assign it to be equal to, and now we're going to use that which function. So let's see what the which function produces. So I'm just going to highlight this piece right here, and to make it clear, let's actually just put it in its own line right here. So we already saw what the y greater than 20 produced. Let's see what which y greater than 20 produces. All right, so which y greater than 20, what it did was it gave me the index for the elements that were greater than 20. It returned the index that returns true. And so this is where people get confused with the which function. The which function is not going to tell me the elements of my object that satisfy my condition. It's going to tell me the index of the elements that satisfy that condition. So again, let's assign this object greater than 20. And notice this object is now going to be equal to 3, 4, and 5. So I know that the elements in the 3, 4, and 5 index of y are greater than 20. So what I can do is if I call my object y, feed it the index numbers that are greater than 20, I will get back my 3 elements of y that are greater than 20. So the which is kind of this intermediary step where, again, it gives me the index, not the elements, but I can then use those indices to pull the elements I need. And this is what can make the which function really powerful, but it can also be confusing when you first learn it. And so notice here I can define a new y, which is equal to those elements which are greater than 20, and so I get a new y is equal to 30, 40, and 50. Lots and lots of useful logic operators. One of the ones you want to be the most careful with, it always trips me up, is the equal to. Since the equal sign is an assignment operator in R, we can't use the equal sign as a logic operator, so we have to use the double equal sign. So for example, if I wanted to know which element of y was equal to 10, I'm just going to type it down here in the console. So if we had which y, and I want to know which one of the elements of y was equal to 10, I have to use the double equal sign. And notice it returns the first index because the first element of y is the one that is equal to 10. Right, so again, take a moment, look through those. If you want to kind of play around with it, use the which function. And what I would do is before you actually use the function, see if you can determine, the index that you think the which function is going to return, and then see if you get that index. And if you do, then you'll have a pretty good understanding of how the which function works. All right, so another useful method of summarizing a vector is the table function. So let's look at the table function. To do that, I'm going to create a new vector here, and I'm going to use what's called the R binom function. So if you're not familiar with a binomial distribution, which is what this is going to pull from, that's perfectly fine. And you don't need to worry too much about this. I'm just using this to create a pretty big vector. So let me talk about what this is going to do, and then you'll see why a table function would be useful here. Essentially, what I'm doing is, what this function is asking me to do is I'm going to flip a coin 10 times. And that coin has a 50% probability of landing on heads or tails. And so what R is going to do is it's going to flip that coin 10 times, where that coin has probability of half the time it lands on a head, and it's going to count the number of heads. So let's say I flip the coin 10 times, and 8 times it lands on heads. So R is going to return an 8. And then it's going to repeat that process 10,000 times. So the resulting vector that I'm going to get should be of length 10,000. So let's run this. So notice that our binom does have 10,000 elements in it. Now, I might want to summarize those 10,000 elements. Now, since those elements represent in 10 flips how many heads I would get, I know that the only values that I could get are 0 through 10. I could get anywhere from 0 heads to 10 heads out of 10 coin flips. So the table function will be really useful in summarizing this, and so let's see what that looks like. All right. So what this tells me is, out of my 10,000 flips, there were only 8 flips out of 10,000 where I got all 10 of the flips were heads. There were 13 of the 10,000 where I got no heads. And remember, that coin is fair, so we would expect probably around half of them to be a heads, and we can see that 2,457 of the flips resulted in a heads, and so on. So if you have a vector, or if you have data that the possible outcomes are fairly small, but you have a lot of data, the table function is a really nice way to quickly summarize that. So if you had survey responses from people and they responded yes, no, maybe, so that's character, but you can still use the table function to summarize that. All right, so next let's look at matrices and arrays. So a loose definition of a vector is a one-dimensional array of data. A loose definition of a matrix is a two-dimensional array of data. So you can think of having a bunch of vectors side by side, essentially. Most of the time when if we close our eyes and we picture what data is going to look like, a lot of times it's really in a matrix. Now in R we can specify what's called an array, and an array is a multi-dimensional matrix. That's essentially what it is. Although vectors and matrices are treated as separate cases in R. So let's look at some matrices. So the first thing we could do is we could create a matrix by creating a blank matrix and fill in the elements. So I'm going to let I'm going to assign it to be a matrix. I'm going to fill it within A's. It's going to have 3 rows and 2 columns. All right, so we're going to run that, and then let's actually see what A looks like. So notice here, A is a matrix that has 3 rows and 2 columns, but there's nothing in it. It's empty. So we're going to fill it, and one way that you can fill it is just by calling each of the individual elements, and you'll notice we're calling these elements just like we did with the data frame. So essentially what I'm saying here in this line is, in matrix A, I want the element in the first row and the first column. So in other words, we're talking about this element right here. I want to set it equal to 3. So we can run this line of code. Now let's check on A, and we see that 3 has filled that space. And we could go through and do that for all of them. And we see that R fills in the matrix. Now you can imagine if you had a really big matrix, that would take a lot of time. So we really usually don't fill our matrices this way, but it is a good visual way to see how to access different elements of the matrix, and to see how to fill that in. But another approach would actually be inside the matrix call itself. So you'll notice here I put in A, and R filled in all of the spaces in the matrix using an NA. Well, alternatively, what I could do is I could give R a vector of data, and what I have to do is I give it the vector of data, I tell it how many rows, how many columns, and then I have to tell it how to go through and fill that in. So this first line of code, I don't do that. Here I just give it the vector and I say 3 rows and 2 columns. So let's look at B and figure out what R did. Alright, so my vector up here went 3, 4, 1, 8, 6, 7. So notice R went 3, 4, 1, 8, 6, 7. So essentially by default, R will take that vector you give it and it's going to fill in the columns. And so it's just going to take that data and just pop it in there one at a time as it runs through the columns. Now you might want to do something different. You might want to do it by the rows. So you can add in by row equals T, and it does have to be a capital T, and that is the short form of true in R. We could have also written out true here as well. Either one will give the same result. Notice that R changed that to a different color, and that's because R knows that capital T and in all capitals true stands for true. It's a logic. So let's run this, and now let's look at C, and we can see what R did now was we went from 3, 8, 4, 6, 1, 7, 3, 8, 4, 6, 1, 7, and it filled it in by the rows. Now, it ends up that B and C are the same, but the only reason they're the same is notice the order which we gave it the vector was different, and we did that because we told R to read it 2 different ways. So when you're filling in matrices this way, you do want to be very careful with the by row or the by column, because otherwise you can end up with very different results. So for example, if we had set the by row equals to false here, notice that we would end up with a different matrix. Alright. We could also create a matrix from vectors. Essentially, you can just put the vectors together as long as they're the same length. So let's have 2 different vectors here. I'm going to call one row 1 and row 2, and let's see what those look like. So we've got row 1 and row 2. And we could either use what is called R-bind or C-bind. So let's look at the difference in these. Alright, so when I use R-bind, R, and R-bind stands for row bind, R is going to bind each of these vectors together like they are rows. So notice there's our first vector, there's our second vector. On the other hand, when we use C-bind, oops, I meant to come down here, notice C-bind is going to combine them together as if they are columns. So looking here, we have a 2 by 10 matrix. Here we have a 10 by 2 matrix. So again, being careful with our dimensions. You can perform operations on matrices. You can find the transpose. So lowercase t is the function for a transpose. You could add your matrices together, or you can do matrix multiplication. I put this more in here for 2 reasons. One, if you do need to work with matrices to know that you can. Again, we're going to be primarily focused on data, so we're not going to do a whole lot of matrix operations, but I do want to make you aware of it. The other thing, this is a good illustration when it comes to multiplication. I realize that's spelled wrong. To be careful, we talked about before how the asterisk by itself is the multiplier. So for example, if we had 2 times 3, 6, but with matrices, we actually want this piece right here is matrix multiplication. So just something to be aware of. We can also apply functions to matrices, and this will become handy as we work with data. What the apply function does is it allows you to apply the same function to either the rows or the columns of a matrix. Well, remember that a data frame looks a lot like a matrix. So if the data that you have is formatted much like a matrix, and it would make sense to apply the functions, you can also use the apply with data frames. So let's see what this looks like. So looking at the inside, what these three arguments tell R to do is that the first argument is the matrix you want to work with. So we're going to work with B. So just to remind ourselves, this is the matrix B. The 1 tells R whatever function we work with, use that function and go by the rows. And then the last argument is the actual function that we need. So running this, notice we get the numbers 11, 10, and 8. Well, 3 plus 8 is 11, 4 plus 6 is 10, and 1 plus 7 is 8. Alternatively, if we change the second argument to a 2, this will apply it by the columns. So notice that these three numbers together, these three numbers added together, oh, sorry, we're taking the median, not the sum, my bad. Notice that the median of these three numbers is 3, and the median of these three numbers is 7. All right, so this next piece right here, I'm going to have you run on your own. This is just a simulated example that you could see how we could use to store some data using that R binom function. So remember that the R binom function is just like flipping a coin. And if you have any questions on this, let me know. But I'll add a little note in here that just says recall. What this would be doing is this would flip a coin 25 times with probability of success 0.5, and it's going to repeat 4 times. And in terms of the simulation listed up above, that will match. All right, and this is going to show how to give column names to that data set and row names. All right, so the last thing we're going to look at is what is called an array. So essentially an array is a lot like a matrix, it just has higher dimensions. I'm going to go through this part pretty quickly because I don't think we're going to work with arrays. If you have more questions about arrays, you can let me know. But I put this more in here for completion than something we're actually going to work with here in the course. So to start out with, I'm just going to define temp, TMP, to be equal to the numbers 1 through 8. So we can see TMP down here. And then I'm going to set G to be equal to an array that's going to take the values from temp and put it in dimensions 2, 2, 2. So in other words, it's going to have 2 rows, 2 columns, if we were thinking of a matrix, and then it's going to come out another dimension. So let's look at what G looks like. So you can think of, almost think of like a Rubik's Cube would be one way to think of this, where this is one side and this is the second side. So really this is a 3-dimensional object. It's got 3 dimensions, but R can only show it to you in 2 dimensions, so it shows it to you in slices. And we can check some data types here. Remember that we defined D earlier on. That was one of the matrices we looked at. And so we can see that D is both a matrix and an array, but G, that 3-dimensional object we just created, is not a matrix, it is an array. So the higher dimensionals can only be stored as an array, but matrices are considered both matrices and array. And then the very last thing to talk about here is in terms of, we've got these different data types. We might have to manipulate the data type. So here we're going to ask R to create a vector. We can see, is it a matrix or is it a vector? We see it's not a matrix, it is a vector, but maybe for some reason we need X as a matrix. So I'm going to define X.M as matrix X, so it's going to change our vector X into a matrix. And we can see here, okay, is X a matrix? It is. It's no longer a vector, and X.M looks like this. So again, be careful with your data types. That's one of the big things to realize here is different objects are going to be stored different ways, and how we apply functions to them is going to be determined by what data type they are. Now just a word of caution here at the bottom, sometimes R will not make a variable into a matrix even if we use .matrix. So make sure to check that R has actually changed the data type, and this is good advice no matter what we're trying to coerce it into, especially last time we talked about coercing into a data frame. So anytime that you do that coercion, always make sure to double check that it actually occurred the way that you wanted it to. And that is going to end the Module 3.1 video.